Hello everyone. Let me just make sure that the stream is working, audio is working and such before we get into the video. If you're watching this in the future, I'm just streaming these so that I don't have to worry about uploading stuff and everything will be uploaded by itself. So I just want to make sure that everything is working. Hello everyone. Yeah, okay. Everything appears to be working. So, brief rundown of what we're doing in this series if you're new. Let me put this away. We are going through the neural networks from scratch in Python book, but we're doing it in Golang, as you can see. Now the book, you need to pay for the book if you want to buy it. Let me just open up my copy. It comes as an ebook, or you could buy like a hardcover or a softcover, I believe. No, I want this to be a split screen, please. Thank you. Along with this, yes, please. Okay, and that's it. No, that's all I want. I just want you guys. Okay, so yeah, you need to buy the book. Here it is, Neural Networks from Scratch in Python. We are, as I said, doing it in Golang. How's the font size? I think this font size is good. If you want to buy the book, there's a link to it in the description. Excellent book, or you could just go to nnfs.io, and that will take you right to their website. Very cheap book for the value you're getting. You could buy the ebook for 30 bucks. You could buy a what is this? I don't know, paperback book for 75, or the hardcover book for 85. It's an excellent book, especially if you program in Python and you want to get into machine learning and get a better sense of what's going on in machine learning. For us, I've gone through this book before, and I just thought it would be fun to go through it, but translate everything over to Golang. So that's exactly what we're doing. If you haven't seen the previous videos and you want to follow along with us here, I recommend seeing them. If you only came here to get a sense of how to do tensor manipulation in Golang, then just watch this one. I think that this will be a very good tutorial for tensor manipulation in Golang, because I haven't really seen stuff like that out there. There's not a whole lot of documentation or tutorials for tensor manipulation, matrix manipulation in Golang. Most people tend to use NumPy and Python for that kind of stuff, and while that's excellent, still I think that it'd be good to learn how to use it in Golang. So in the previous video, we were doing chapter 2, coding our first neurons. We had this whole thing set up, just a quick review. These are our inputs, these are our weights. We have 3 neurons, as you can see, because there are 3 sets of weights. Each one of the weights corresponds to an input. There are 3 biases, 1 for each neuron. And here we have the layer output, and here's the for loop that's going through all the weights and using each neuron, each set of weights for each neuron, and using the bias, it's getting out, it's doing the math to get the output, and then putting that output into the layer outputs and putting that output. And if we run this code, I need a new terminal, go run everything. That's weird. Okay, right, I have to cd into chapter 2, cp2, and then I could do go run everything. You see the layer outputs is 4.8, 1.209999, and 2.385, which is exactly what the author of the book got in his Python thing. This is his Python code. Where did we get up to? We got up to, yeah, so this is his output from this exact code. This is the code in Python. Again, if you want to get the whole book, highly recommend it. You can buy it, link in the description. Okay, so we ended last time, he was about to start talking about tensors, arrays, and vectors. And so if you don't know what a tensor is, if you're coming from something like PyTorch or TensorFlow, and you use tensors but you don't really know what they are, you don't really have an understanding, this video is for you. Along with the author of the book, has a tutorial series where he goes through this. That's also linked in the description. So if you want to learn this in Go, this is the video for you. If you want to learn how to do tensors in Go, this is the video for you. If you want to learn what a tensor is and how to use it in Go, this is the video for you. So stay here, and well, stay tuned, and we'll go through it. So it's funny because I was just thinking last night when I was thinking about this part of the video, I was thinking like the main thing to focus on is just doing tensors in Golang, because I've never done that before. But then I remembered that many people don't actually know what a tensor is. And it's important to do that. And it's important to learn what a tensor is. And it's really simple. Tensor is actually not a complicated idea. And he's going to explain it right now. So let's see what he has to say. And then we'll see what he does in his Python thing. And then we'll see what we do, what we do in our Golang script. Okay. What are tensors? Tensors are closely related to arrays. Yeah, they are very similar to arrays, or in Golang, slices, anything. When he says arrays, I think he means NumPy arrays, which basically NumPy arrays are tensors, but anyway. If you interchange tensor, array, matrix, when it comes to machine learning, people probably won't give you too hard a time. Whenever we say tensor, we mean something very similar to an array or a matrix. When it comes to machine learning, we use these words interchangeably. Personally, I use tensor the most because both PyTorch and TensorFlow call their structures tensors, and those are the things that you use. But if you use a NumPy array is pretty much a tensor in the same way. So if you're coming from NumPy and you know what NumPy arrays are and you have a good understanding how to use them, their shapes, their sizes, how things interact, you already know what a tensor is. Already, you're done. You're finished. If you don't, then we'll get the understanding. But there are subtle differences between a tensor array, a matrix, etc. There are differences, and they are primarily either the context of either the context or attributes of the tensor object. To understand a tensor, let's compare and describe some of the other data containers in Python. I'll show in Golang. Things that hold data, that's what a data container is. Let's start with a list. A Python list is defined by a comma, separated objects contained in brackets. So far we've been using lists. So he's been using lists, we've been using slices. Let me just comment all of this. And also I decided that I'm just going to have that. So for us, a list would simply look something like this. I guess we'll follow his syntax. L colon equals, he's doing integers, so int 32. A slice of int 32, and this is our notation 1, 5, 6, 2. And this is the exact same thing essentially between us and between him. So yeah, we use slices or whatever they're called. I'm not exactly sure what they're called. You could call a slice, a list. I don't know what they're called in Golang because Golang has so many different terms and they all mean different things, but I'm not subtle enough yet in that area. Then we have something called a list of lists, which is a very similar syntax. You just have, we're going to put another bracket over here. Let's expand this open a little bit. We're going to put these in curly braces because now we have a list of lists. And we'll add another row of 3, 2, 1, 3. So you see, not a period, rather a comma. So he has this structure set up, and this is how it's done in Python, and this is exactly how it's done in Golang to make a very, very similar structure. If not, you could even call it identical structure. Then you could have a list of lists of lists. So let's even do that. So the way we would do that is denoting this. So this is a list of lists. By the way, if you didn't know how to do multi-dimensional lists in Golang, this is how you do it, by the way. So let's add another list over here. Oh boy, things are going to get really intense now. And then we have to actually, let's cut all of these. And we have to expand each one of them, because each one of them is now its own list. And each one of them will have a list inside of it. So 1, 5, 6, 2. And then he has 3, 2, 1, 3. And then he has, honestly, no, I can't just copy and paste. Then he has 5, 2, 1, 2, 5, 2, 1, 2. And then the next one he has is 6, 4, 8, 4, 6, 4, 8, 4. And then the last but not least, he has 2, 8, 5, 3, 2, 8, 5, 3. And then this is the actual last one, 1, 1, 9, 4. So here we have a list, that's the purple braces, of lists, that's the blue braces, and then last but not least, of lists, and that's the yellow braces. So we have a 3-dimensional list. Everything shown so far could also be an array or an array representation of a tensor. A list is just a list, and it can do pretty much whatever it wants, including, this. So everything that we've done up until now, including every example that I've shown and every example he's shown, could basically be called a tensor because of how it's structured. The problem is when you have things that look like this, things that aren't uniform. So if I take this away, now we would call this in the language of machine learning, this thing doesn't have a uniform shape. One of the lists is missing a number. And so this is not a tensor. This could not be represented as a tensor or an array, whatever you want to call it. This is simply a 3-dimensional list in Golang, and it works. Golang allows this. So it's not really a tensor. This is a tensor. The above list of lists cannot be an array because it is not homologous. That's a term. It basically means it's not uniform. A list of lists is homologous. homologous, I don't know. If each list along a dimension is identically long, and this must be true for each dimension. So let's break that down. Each list along a dimension is identically long. So in a given dimension, let's say this big thing is the first dimension, the blue braces are the second dimension, the yellow braces are the third dimension. It must be, it's only homologous if, let's see, identically long, if each list along a dimension is identically long. So let's take a look at the third dimension, the orange braces. So it's only homologous, whatever, if every single list in this dimension is the same length. As you can see, it is. If I were to take this one away, then it's no longer. Okay. The first dimension's length, so in the example, the first dimension's length is a number of sublets in the total list 2. Not sure what he just said there. The second dimension is the length of each of those sublets, 3 then 2. In the above example, when reading across the row dimensions, also called the second dimension, the first list is 3 elements long and the second list is 2 elements long. So you see this one is 3 elements long, this one is 2 elements long. This is not, whatever the word is, I'm going to give up. Maybe I could like ask someone to pronounce this. Pronounce this.
Homologous.
Homologous. Okay. This is not homologous and therefore cannot be an array. When failing to be consistent in one dimension, when failing to be consistent in one dimension is enough to show that this example is not homologous, we could also read down the column dimensions, the first dimension. The first 2 columns are 2 elements long, while the third column only contains 1 element. So yeah, you could do it by looking at the columns. This one is 2, this one is 2, this one is only 1, so something is off. Note that every dimension does not necessarily need to be the same length. It is perfectly acceptable to have an array with 4 rows and 3 columns, i.e. 4, 3. So you see, it's totally fine to have, let's simplify this down a little bit to be a list of lists. A list of lists, and let's get rid of this guy. So to only make it 2 dimensions. It's okay to have 2 lists here, and each one of them have 4 elements. As long as things are uniform in their given dimension. Right, I have to get rid of one of these brackets. As long as things are uniform in their respective dimension. So there are more elements here than there are here, like in this dimension. This is getting confusing. But that's okay. You could have a 4x3 thing. You could have a, what is this, a 2x4 thing. It doesn't matter. The problem is when you have things like, you can't even say, if you cannot say this is a 4x something thing, then it's no longer an array. So this is a 2x, well, we're not sure what it's by because there's 3 here and there's 4 here. So it cannot be an array. All right, now let's start getting into exactly what is a matrix. A matrix is pretty simple. It's a rectangular array. It has columns and rows. It is 2-dimensional. So a matrix can be an array, a 2D array. Can all arrays be matrices? No, not all arrays can be matrices. An array can be far more than just columns and rows, as it could have 4 dimensions, 20 dimensions, and so on. So an array is basically, a matrix is a 2-dimensional list. So for example, this would be a matrix. It's a list of lists of numbers. If it's a list of lists of numbers, if you could describe its shape with 2 values, 4x3, then it's a matrix. This one is a 1, 2, 3. This one is a 3x2, I think. I mean, maybe it could be a 2x3, but I think it's a 3x2. Yeah, it's a 3x2. So that would be a matrix. What's not a matrix is if I added another bracket here, and now we start making things more dimensional. So we have, yeah, as you can see, if we start getting things to be bigger in terms of dimensions, then, oh boy. Yeah, okay, and let's just copy this. This is a, well, let's see, this is a 2x2x4, right? It's a 2x2x4. There are 2 big lists in this, in our big list, in our actual list, in L. There are 2 lists, and then each of those 2 lists have 2 lists, and then each of those 2 lists have 4 values. So this would be a 2 by 2 by 4. You see how there are three numbers there, 2 by 2 by 4, 2 by 2 by 4. That's no longer a matrix. At that point, it's an array. So an array is a matrix, but not all matrix. Sorry, hold on. A matrix is a kind of array. An array basically means a multi-dimensional structure. A matrix is not necessarily an array, or a matrix is a kind of array, but not all arrays are matrices, because this is an array, but this is not a matrix. Matrices have two values in their shape. That's what the 4 by 3 is. That's called a shape. Matrices have two values in their shapes. Arrays could have many more. They could have n amounts. Okay. The above list could also be a valid matrix because it has rows and columns. So you see this one has clearly rows and columns. It has 3 rows and 2 columns. This one doesn't really have rows and columns. Like it has, I guess you could call these rows, it has 2 rows, and then each of those 2 rows has 2 columns, and then each of those 2 columns has 4, like something. This doesn't make sense in language, right? Sorry. So this thing over here could be a matrix. The shape of, and it's an array, which automatically means it could be an array. The shape of this array would be a 3 by 2, right? It's called a shape. Formally described as a shape of 3 comma 2, as it has 3 rows and 2 columns. So the syntax, this shape is 3 comma 2. That's what we mean when we say shape. And when we say 3 comma 2, we mean it's a 3 by 2 structure. And if you've been using TensorFlow and stuff like that, and you've been getting errors of like invalid shape situation, and you're like, I don't even know what a shape is, that's what a shape is. It's that simple. It's just a way of describing the dimensions and the amount of values in each dimension. By the way, if this is confusing, don't worry about it. It was super confusing for me when I first learned it, and it took a while to get a real intuition of things. But you'll get there. Don't worry about it. You'll be fine. To denote a shape, we need to check every dimension, as I've shown you. As we've already learned, a matrix is a 2-dimensional array. The first dimension is what, and by the way, if you want to review what we're doing in these videos, you could buy the book and go through the book as a review to the videos, or you can buy the book and read the book and then review the book through the videos, and it's a good way to review. I recommend, in short, I recommend buying the book. It's a good book. Okay, the first dimension is what's inside the most outer brackets, and if we look at the above matrix, we can see 3 lists there. So if you look, so this is how we determine a shape. This is how we can tell what a shape is. So there are 3 lists in our big list, and over here there are 2 lists in our big lists. We see 3 lists there. So the 3 lists in his one are 4 comma 2, 5 comma 1, and 8 comma 2. Thus the size of this dimension is 3. And each of those lists has to be the same shape to form an array. So there has to be the same amount of values in this one as there are, in this one as there are, in this one for it to be called an array. And matrix in this case. In this particular case, it's both an array and a matrix, but not always will you have an array that's also a matrix. The next dimension's size is the number of elements inside this more inner pair of brackets, and we see that is 2, as all of them contain 2 elements. So there are 3 lists in our big list, and each one of them has 2 values, and so we say it's a 3 by 2. Okay, now he's going to talk about 3-dimensional things, 3-dimensional arrays. This is no longer a matrix. This is called an array because it's not a row and column situation. We'll have a 3rd level of brackets. So this one looks kind of confusing because there are like 3 brackets here. I like how Golang would show it. There's the big brackets, which is our general thing, and let's even call this the same thing. List of lists of lists. So this is our big list of lists of lists. Here is a list of lists. Here's one of the 2 lists of lists inside our list of lists of lists. And here is one of the 2 lists of numbers inside our list of lists, which is inside our list of lists of lists. It's a whole thing. So let's break it down. The first level of this array contains 3 matrices in his one. There's 1, 2, 3. In our one, it's 2. We have 2 blue brackets. 1, 2. That's the first level. That's the first dimension. And those are his ones. Okay. That's what's inside the most outer brackets, and the size of this dimension is then 3, because he has 3 of them. In the first level of our most outer bracket is 2, so we have a size of 2 in that dimension. If we look at the first matrix, so this is now a matrix. It has columns and it has rows. So this is now a matrix. The array contains an array. Another way you could say it is the array contains a matrix, right? So in his one, he has 2 in each, and in our one we also have 2 in each. 1, 2, and then also 1, 2. His one is 1, 5, 6, 2, 1, 5, 6, 2, and then 3, 2, 1, 3, 3, 2, 1, 3. So the size of this dimension is 2. That's actually the same for us. So his first dimension is 3. Our first dimension is 2. His first dimension is 2. His second dimension is 2. Our second dimension is also 2. While each list of this inner matrix includes 4 elements, these 4 elements make up the third and last dimension of this matrix, since there are no more inner brackets. Therefore, the shape of his array is 3, 2, 4. And it's a 3-dimensional array since the shape contains 3 dimensions. See these 3 dimensions. So our shape would be 2, 2, 4, because we also have 4 things. And this would also be a 3-dimensional array because our shape also has 3 values. Okay, so there you go. That's your first introduction to shapes and tensors and stuff like that. Not even using NumPy or TensorFlow or PyTorch or the thing that we'll be using, which is a Golang Tensor Library, which I'll show later in the video. But what else? What else did I want to mention? Right, this could go on. The thing that we've just done in terms of determining shape could go on for infinity. We could have n dimensions, any amount that you want. The problem is visualizing a 4-dimensional situation is hard. And even if I were to write it down here, it would be a mess. So we're not going to do that. Just stick to 3 and then extrapolate it out in your mind. Okay, finally, what is a tensor? So here's the real thing. So the difference between a tensor and a matrix, as we've seen, was that a matrix is 2-dimensional, and then an array could be however many dimensions you want. But what about a tensor? Why is a tensor different than an array? When it comes to the discussion of tensors versus arrays, in the context of computer science, pages and pages of debate have ensued. This intense debate appears to be caused by the fact that people are arguing from entirely different places. By the way, I don't even remember this, so this is interesting for me too. There's no question that a tensor is not just an array. So tensors are not arrays. But the real question is, what is a tensor? To a computer scientist, in the context of deep learning, we believe that we can solve the debate in one line. Okay, so here we go. A tensor object is an object that can be represented as an array. That is clearly a loaded thing. The loaded of the part is the can be represented. So a tensor could be represented as an array, but it's not an array. Why is it not an array? Let's see what he says. What this means is, as programmers, we can and will treat tensors as arrays in the context of deep learning. So we're going to be treating arrays like tensors and tensors like arrays. There's not going to be a real difference. And that's really all the thought we have put into it. Are all tensors just arrays? No. No, they are not just arrays. I don't know why, by the way. I don't know why. He knows why, but he's not saying. But they are represented as arrays in our code. So to us, they are only arrays, because for us there's no visual difference between an array and a tensor in computer science, apparently. And this is why there's so much argument and confusion. Okay, so by the way, just heads up, clearly there's some math behind this, that tensors are something else, and they're used in math as something else. They have attributes that are not like an array's attributes, but apparently for us in computer science, we don't really deal with any of the differences, and for us, tensors are the same things as arrays, basically. The differences between them don't really come up in the way that we deal with them. So I've never taken anything higher than high school level math, just by the way. So I don't know. I don't know what the differences between tensors and arrays would be. I'll probably learn it at some point in college. But I'm interested. This is interesting. I forgot this part. I thought that tensors were just a funny word for arrays, but that's because I coded so much, and apparently they're the same thing in coding, which is why it gave me that false illusion. So anyway, okay, now what is an array? In this book, we define an array as an ordered homologous container for numbers. Ordered homologous container. Homologous again means that everything is uniform in terms of the shape. And I'm not sure what he means by ordered, but I don't know, we'll see. and mostly use this term when working with the NumPy package, since that's what the main data structure is called within it. So the main data structure in NumPy is an array, and they do linear algebra stuff with those arrays in NumPy. A linear array, also called a one-dimensional array, is the simplest example of an array, and in plain Python this would be a list. So again, a linear array would basically look something like L colon equals, we've done this before in 32, 1, 2, 3. This would be a linear array. What would be the shape of this array? 3. That's it. It's a one-dimensional thing. 3. There are 3 values here. So in Python it would look like L equals 1, 2, 3, but that's not Golang syntax. So this is Golang syntax. This would be a one-dimensional array, but it's not a one-dimensional array. Just to be clear, this is a slice. In order to call it an array, we would have to make a bunch of code behind it that quickly would do the linear algebra operations, and I found a library to do that, thank God, so I don't have to do it by hand. Okay. Arrays can also consist of multi-dimensional data, not just numbers apparently, and one of the best known examples is what we call a matrix in mathematics. A matrix is a kind of an array, which will represent as a two-dimensional array. So matrices we will represent simply as a two-dimensional array because for our purposes that's exactly what it is. Each element of the array can be accessed using a tuple of indices as keys, which means that we can retrieve any array element. I'm going to show you guys how to retrieve elements in our arrays or tensors using there's an ant on my camera. I'm going to show you guys how to achieve these values, how to retrieve these values. So you have a big matrix or a big array, and there's a syntax that we use to retrieve the values. We need to learn one more notation, a vector. So this is interesting. I'm not exactly sure what a vector is. Put simply, a vector, I think I know what a vector is. It's just 2 numbers. A vector in math is what we call a list in Python, or a one-dimensional array in NumPy. So a vector is simply, this would be a vector, apparently. It's just a one-dimensional list. Of course, lists and NumPy arrays do not have the same properties as a vector, but just as we can write a matrix as a list of lists in Python, we can also write a vector as a list or an array. So these things aren't exactly the same, but in computer science, they could be represented using the same structures. Additionally, we'll look at the vector algebraically, mathematically, as a set of numbers in brackets. So for us, it's going to be curly braces. This is in contrast to the physics perspective, where a vector's representation is usually seen as an arrow. That's how I understand vectors, characterized by a magnitude and a direction. So a vector in physics could be like a magnitude, and then a direction would be like an angle from a origin, or a vector could simply be a point from another point, so 2 values. But anyway, that's physics, and apparently in math, vectors mean simply this. This is a vector. This is an example of a vector. Okay. That is your crash course in vectors, tensors, stuff like that, without using the library. Now we will move forward, and when I publish the video, I'm going to put timestamps and stuff. So this was the end of the introduction to shapes and tensors and stuff like that, and now we're going to start talking about the things that we could do to arrays, or apparently vectors. Okay, so the dot product and vector addition. Let's now address vector multiplication, as that's one of the most important operations we'll perform on vectors. So let's see how we multiply vectors. We can achieve the same result in our pure Python implementation of multiplying each element in our inputs and weight vector element-wise by using a dot product, which we'll explain shortly. Let me just show exactly. I'm going to just cut ahead of him for a second. So actually I could delete all this. And I'm going to uncomment, the things that we had. So either watch the previous video or quickly review very basically what we did in the previous video. We had our inputs, which were a vector, apparently, using our newfound syntax. We have our weights, which are a matrix. Each one of the vectors in our weights is a neuron's weight, respective to each neuron, and each bias is also respective to each neuron. We have the layer outputs, and okay, I want to focus here. The neuron output plus equals inputs at index j, so we're looping through our inputs, times the neuron weights at index j, so we're looping through a specific neuron weight. This right here is basically the dot product. This is called a dot product. We're taking the sum of all the respective values and multiplying them together. So that's what he means when he says a dot product, and he'll go through it more in depth right now. Traditionally, we use dot products for vectors, yet another name for a container, and we can certainly refer to what we're doing here as working with vectors, just as we can call them tensors. Nevertheless, this seems to add to the mysticism of neural networks, like they're these objects out of a complex multidimensional vector space that we'll never understand. Keep thinking of vectors as arrays. A one-dimensional array is just a vector or a list in Python. So that, I'm not sure what that paragraph is doing, but anyway, it's a book. They go slower than a video might, so we're just blowing through these paragraphs because I don't think they're that important for the video. Okay. Because of the sheer number of variables and interconnections made, we model very complex and non-linear relationships with non-linear activation functions and truly feel like wizards, but this might do more harm than good. Yes, we will. If you want to read the book, read the book. These paragraphs, I'm not exactly sure if we need to cover them. When multiplying vectors, you either perform a dot product or a cross product. So imagine you have two vectors. Let's comment this stuff out again. The reason why I keep commenting is because we're going to go back and use it, and we're going to turn it into array syntax. But imagine you have two vectors. You have a vector x, which we'll just, for now, we'll show as just a list, 1, 2, 3. And then we have a y, which will show, and by the way, this, you could just say a one-dimensional array. Let's say we have a one-dimensional array. I'm going to say one-dimensional array instead of vector. Let's say we have 4, 5, 6. Okay, what if I said x times y? Or rather, z equals x times y. What do you think z is? First of all, you can't do this. You're not allowed to do this in Golang, so that's why we need the library, because I want to be able to do things. I want to be able to write things like z equals x times y. But what would this mean? Well, there are two main ways we do multiplication when it comes to one-dimensional arrays in mathematics. One of them is we say, okay, 1 times 4 plus 2 times 5 plus 3 times 6. That is the dot product. You're taking each index and you are multiplying them and adding them together. So this would be 1 times 4 is 4, plus 2 times 5 is 10, so that's 14, plus 3 times 6. 3 times 6 is 18. 14 plus 18 is 32, right? 32? I think so. So z would be 32. Notice how z is a number. It's not a vector. It's not an array. Z is a number. When you do the dot product, that's what you get. You get a number, or you get something called a scalar. And he's going to show exactly, this is how it looks like in math notation. So a times b, which we have over here, x times y, and these arrows up here denote that they're vectors or one-dimensional arrays. That equals the sum, I'm not sure what this means. As long as, maybe this is supposed to be an equals. I equals 1 until I equals n of a times b equals the first a times the first b plus the second a times the second b, until the end. So you see the first x times the first y plus the second x times the second y plus the third x times the third y. And then that's all in z, and so that's a number. A dot product of two vectors is a sum of products of a consecutive vector elements. Both vectors must be of the same size, have an equal number of elements. So you cannot do a dot product like this. This wouldn't work because it's going to get up to here and it's going to be like, well, I need some value over here and I don't have it, so it's not going to work. Then there's the let's write out a dot product. Let's write out how a dot product is calculated in Python. For it, you have two vectors, which we can represent as lists in Python. You don't need to be writing this stuff down in your own thing, I think, because this is all just introduction. You just have to remember this. If you want to write this down in your own file and structure your code differently, please by all means do that. But the real meat and potatoes is here, and once we get through all this information, we'll start translating all of this into things like this in code. So let's write out how this dot product would be done, but not in Python. We're going to do it in Golang, which can be represented as a list in Python. Okay, very good. So here, so we already have most of the building blocks. He has an A and a B, so let's change that. Instead of X and Y, we'll have A and B. Okay, and the dot product. So to obtain the dot product, let's see, dot product colon equals. So for us, it would be, why is this B and B? I don't want this to be B and B. I want this to be A and B. A index 0 times B index 0 plus, and then I'm just going to copy this and paste it twice. No, stop it. 1, 2. And instead of 0, this will now be a 1. And over here, instead of 0, this will now be something's weird. Oh no, 2. Okay. So this is the dot product in our very simple example. Normally you would want to do a for loop, right? This is very easily done with a for loop. You set the variable of dot product, you loop through it, and that's exactly what we did over here. This is a dot product. The neuron output is a dot product. That's like mind-blowing. The neuron output is a dot product plus the bias. That's what it is. It's crazy. So anyway, yeah. So here he has the dot product. He's using different values than we are, but here I could just write this fmt.println dot product, and let's run this. Go run everything, and we get 32. So our value is 32, which is pretty cool. But another, like, a few key things to notice that I want you to notice. Let's just do one, because a few might be hard to swallow. Here we have one-dimensional arrays, also called vectors. Notice how when you do the dot product on them, you get a number. You don't get a vector. That's important. Just throwing that out there. It's important for physics. It's important for math. It's a cool thing. Okay. Yeah, he has not covered cross product yet. Cross product is the other way we do a multiplication between one-dimensional arrays. Cross product's annoying. I hope he doesn't cover it because I don't like cross product. But anyway, okay. Now what if we call A inputs and B weights? Suddenly this dot product looks like a, not sure what this word is, succinct. Succinct. Briefly and clearly expressed. Right. So suddenly the dot product is a very nice, is a briefly and clearly expressed way to perform the operations we need and have already performed in plain Python or Golang. So like I said, he's saying it right now because he's copying me. The dot product, this is a dot product right here. We're looping through the weights and the inputs, and we're performing a dot product on each one, and then we're adding the bias, and then we're putting that into the layer outputs, and we're printing that. And so we're doing a dot product. We're doing a dot product between this, and then adding the first bias. Then we're doing a dot product between this, and adding the second bias. And then we're doing a dot product between this, and this, and then adding the third bias. And then we are putting all of those into this, the layer outputs. And then we're printing the layer outputs, and so we get 1, 2, 3 numbers. And that is our layer output, which is really cool. So instead of doing all this in raw Golang, which has a for loop and crazy things and annoying things, we're going to use a library instead. And he's going to use NumPy, we're going to use our own thing. So yeah, so he's done with this. And now he's going to start turning things into NumPy. So he's importing NumPy, he has his inputs and he has his weights. So first we're going to do a single neuron. We're going to do a single neuron with NumPy. This is an entire layer. We don't want an entire layer. For now, let's just do a single neuron. So let's get rid of this. Okay, and he's using NumPy, so he's already imported NumPy. We're going to be using something different. We're going to be using a Go library called Tensor, the Tensor package. To get this library, go to this link. It's in the description. You could also just go to pkg.go.dev and type in Tensor when you search for packages. Anyway, you get to this library. Just a quick, let's take a look at the introduction. In the data analysis world, NumPy and MATLAB currently reign supreme. Both tools rely heavily on having performant n-dimensional arrays or tensors, which now you know what those are. There's an obvious need for multiple dimensional arrays in Go. Yes, I agree. While slices are cool, a large majority of scientific and numeric computing work relies heavily on matrices, two-dimensional arrays, three-dimensional arrays, and so on. In Go, the typical way of getting multi-dimensional arrays is using something like this syntax, which we've done in this video. Applications that are more math-heavy may opt to use the very excellent GoNum matrix package. So GoNum is a package in Golang, but it's only for matrices. What's a matrix? A matrix is a two-dimensional array, which we want n dimensions. So that's why we're using the tensor thing, because for computer science, tensors and arrays are the same thing. What then if we want to go beyond having a matrix? We want to have a three-dimensional array. It comes to reason that there should be a data structure that handles these things. The tensor package fits this niche. So basically, this is NumPy, but for Golang. And as you can see, you can have a tensor object, which is denoted by T, and you can get the shape and we'll be going through all of these things One thing that I was very happy to see is this t.transpose. We're going to need that, which is important. But anyway, let's install it. So where does he say how to install it? Right over here. To install, go get this thing. And so what you want to do is you want to go to your command line, go get this. If this throws an error for you or something, like it can't find the path to go or something like that, you need to figure out how to install packages in Golang. I recommend you find a tutorial for that on YouTube. Just search in how to install packages in Golang, and then where to find them. And search that on YouTube, follow the tutorial. Maybe if I have time, I'll put a link in the description. But anyway, it should be pretty simple. And this is, so you go get -u, and then this is the path to the thing. And we're going to wait for it to install, which takes a while in Golang, because I don't know why it takes so long for packages to install for Go, but it's much slower than Python. And I didn't do this before the video simply because I want to show you exactly what goes on and give you the full experience. I mean, I did do this before the video, but then I deleted it so that we could do it again. I forgot how long it takes for these things to go. Oh my god. By the way, I'm not even sure what the -u does. What is the -u? We could even search this. Let's find out what this is. Go get -u. Go get. So add dependencies to current module and install them. Yeah, not sure. Are you done yet? Come on. Unbelievable. Let's search for -u. Show documentation for unexported as well as exported symbols and methods. I don't think that this is it. No, yeah, I guess it is. Go, yeah, no. The -u flag requires one or more arguments. Unsure. I don't care enough to look for it. Oh my god, it's still not done. Wow. Okay, anyway, while it's going, let's open up where it will be. So in order to find it, sorry, this is something random. Go to your, I mean, this is where I keep my Go file. I'm not sure if this is the same place or if it's the default place, but anyway, I go to my C drive. I go to users, the username, which is my brother. And then I should have a Go file. So I have a Go file in the users, and then go to source, src. And here we have all of the files of Golang that are on my computer. And so mine, the ones that I write, are in github.com, Alicia Schmalo, and here's all my projects. These are all the things that I do. But anyway, the one that we are looking for will be georginia.org/tensor, georginia.org/tensor. So it's installing the stuff, as you can see, but it's not done yet, apparently. And I'm just going to close this, I guess, just because I'm afraid of that it'll mess it up. But anyway, why aren't you finished yet? Unbelievable. I don't know why it's taking so long. This is taking a minute. I guess it's a really big package, right? Like NumPy is ginormous because there's a ton of stuff in NumPy, so I guess this one's also very big. You know what? We should be happy that it's taking so long because that means that this thing comes with a lot of features. I still don't really know how to use it, so you're going to be watching me learn how to use it. Because like in their tutorial, it says new parentheses with shape 2,2, but new is not a keyword in Golang, so I guess they mean tensor.new to make a new tensor, but anyway. Yeah. Oh my god! This is taking so long. I don't know, what should we do until then? I guess we could take a look at what he's going to do. So he is going to import NumPy. He's going to make inputs and weights as we've seen before. So it's going to have 1, 2, 3, 4 inputs. And there's one weight and there are 4 weights. There's one weight because there's one neuron. There's one set of weights and there are 4 weights because there's one neuron and each neuron needs 4 weights to correspond to the 4 inputs. And then there's just one bias. There's just one bias because there's only one. Why can't I select the last thing? There's one bias because there's only one neuron. And then he's going to show output equals np dot, so numpy dot, between the weights and the inputs, plus the bias. And then print output, and boom, there's his output. So it's that simple. When we had like a for loop going through the whole thing, we had to do all the indexes. NumPy handles it beautifully with just np dot dot, and it's beautiful. So whereas we have, why are there two things here? Oh, anyway. Whereas we have, or we have this whole for loop going on over here that has to go through all the things, and then so this is where we do the dot dot, and then we have to add the bias, and it looks very messy. NumPy makes it look just absolutely beautiful, and our library will do the same thing. So let's delete all of this, except for the weights and the biases, I guess, because we're gonna need that. Are you done yet? Oh my god! Wow. Okay, it's done. It's done. I think it's done. Right? Yeah, it's done. Undefined array.interface. No, it found an error, I guess. Undefined array.interface. Let's just, can we try to do this again real quick and see if it, I think this is an error, I'm not even sure. Tensor, dense compact, line, this. It found an error, I guess, and it errored out. That's weird. I guess that's maybe why it was taking so long, because it had an error and I couldn't get through it. Did it install a package? Do we have it? We have something like it. Yeah, we have the package or something like it. I don't know. Unclear. 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 Don't know. Do not know. I'm following the install instructions, I suppose. That, there aren't even that many instructions. It's quite simple. Sorry if this is taking so long. I'm going to put a tag in the thing between installing and getting back to work, so that anyone that's watching this in the future could skip if they've already installed the package. But I imagine you're having similar problems to me, and so it's good if we work through it. That's why I like doing the live streams like this, because that way you get to see live any problems that I might have and how to fix them, because that's how you learn, really. And so I like that. But if you know how to do it and you don't want to learn that part, and you want to get back to the stuff, you could just skip it. So that's why I'll add this stuff later. Until then. Okay, yeah, so it found the same error, I think. You know, maybe we should even open this up. Tensor, dense compact. I'm kind of tempted to open up this file. I don't know. I'm kind of also tempted to just ignore it and move on and hope that we don't get into an error. Let's just ignore it and move on, and let's basically just hope that we've installed the package, because I don't know what's going on. So, and if we run into problems, then we can deal with that. So let's go back to our Go directory, and you should see something like Go. You should see something like Go Argonia, Tensor, and then this is basically the library, which we will import now. So when he says import NumPy as NP, we will do something very similar. Instead of just import FMT, we will have, do we need commas? I forget. Go Argonia slash, what was it, Tensor? I forget what the link is. goargonia.org slash tensor. Sorry, I forgot the .org. goargonia.org slash tensor. And then let's say T. Okay, Gorgonia slash tensor imported but not used. Could not import this. No required module provides package. So I think this is because we have a go mod here, so we have to run go mod tidy. So let's go go mod tidy. Right, so now it has to download the thing into our module, just because that's how it goes. You know what? The only reason why I set these up as modules, I don't know. We'll deal with it later. I might want to discontinue the whole module idea. But anyway, now it has to get the entire thing down. Right. So right here. Oh God. These are what are these links? How big is this file now? How big is my folder here? How big is chapter 2? What's the size of chapter 2 now? That's the thing I'm interested in. Yeah. Oh boy. NNFS chapter 2 size is 16.4 gigabytes. That's nothing. Okay, fine. So I'm not exactly sure what the gomod.tidy does, but it worked. So, okay, so since he's using NumPy, he's able to just declare these as normal lists and then use the dot product as them, and NumPy will return it properly. I don't think that our Tensor, our library will do this for us, but we could try. There's no reason why we can't try. So let's make this a one-dimensional thing. That's our weights. Bias. Now we're just going to have a bias, colon equals 2.0. And let's just try it out. So T output, not outputs. I don't know why he writes outputs, but anyway, output colon equals T dot. No, here we go. Dot product. Okay, so it expects a T dot tensor, so we're gonna have to change this. So inputs is no longer just gonna be a Golang slice, it's gonna be a T dot new. This is the syntax, you make a new. What's the shape? I forget the syntax, what's the shape? With shape, T dot with shape. So hold on. Yeah, I'm gonna need this documentation. So new T dot with shape, and then the shape is just gonna be like 1, right? It's only 1. Oh no, we need the actual shape. So what's the input shape? The input's a 1, 2, 3, 4. So it's a 4. It's a 4 long thing, and then I think the next one is values. The next option is values, right? With backing. That's what it's called. T dot with backing. I wonder what that function returns. T dot with backing. I wonder if you could just do it like that. T dot with backing. This returns with backing is a construction option for a tensor. Use it as such. Backing colon equals. So I guess we don't even need to pass in the shape. We could just pass in the T dot new T dot with backing. Yeah, like I said, I don't really know what I'm doing here. Float 32. And then what are the values? 1.0, 2.0, 3.0, 2.5. Yeah, I think this is the syntax. T dot new, you're making a new tensor. And then this is the backing for the tensor, like this is what's going behind the tensor, and that's being broadcasted forward, I guess. And then, okay, so we're going to copy the same syntax for the weights. I guess T dot new, T dot with backing, but the values are going to be different. This one's going to be, let's just copy these values, 0.2, 0.8, negative 0.5. Yeah, I think this will work. Okay. And then the bias is 2.0, and then T dot dot, this takes in our two things, so let's see if this works. Inputs, comma, weights. No, something's wrong. Cannot initialize one variable with 2. Cannot initialize. Maybe I need to do inputs dot. No. T dot. X needs to be a T dot tensor. But our X is not a T dot tensor, it's a T dot dense. I'm not sure what dense is. So let's just declare it more forcefully. Var inputs T dot tensor equals. Does this throw an error? No, now it works. Okay, so now it's no longer called a T dot dense, now it's called a T dot tensor. So var weights T dot tensor equals a new thing. And now let's see, T dot dot. What's the error? Can initialize one variable with 2 values. Oh, that's because T dot dot returns 2 things. It returns an error also. I don't care about the error for now. Let's just do an underscore. And then this thing takes in inputs, and it takes in the weights. Okay, great. So it looks like this is working. Now, what if I go back and go back to colon equals syntax? Will it still work? I hope so. Because colon equals syntax is so nice. So I guess a t dot dense is basically its way of saying a tensor with one dimension. I guess that's what it means. T dot dense is a tensor with one dimension. So output that and then plus the bias. Problem. What's wrong? I guess it's just two valued t dot dot tensor value of type. No, because okay, right. So this is okay. So this is returning a two-pronged thing. So I want the first one of them, and then I don't want this anymore. And then okay, now what's wrong? Dot is no. What's wrong? What's the error? Two value t dot dot inputs weight value of type return value dot tensor comma error where single value is expected. So this is returning a tensor thing. And so I guess this thing also needs to be a tensor thing. So I wonder if I could just do t dot tensor as a struct and then it's constructed like that. No, I can't. Nope. No, I have to do t dot new. T dot new, and then t dot with backing. And this is going to be a 2.0. So now bias is a dense thing as well. Nope, still something's wrong. Okay, so that was clearly not the solution. What if I get rid of this? No. I'm learning how to use it, as you can see. How about we say dot product, comma underscore is just the dot product, and then we say output colon equals the dot product plus the bias. Does that work? No, it's not. Okay, right, because this thing needs to go away. Okay, nope, this doesn't work. Why? Invalid operation dot product plus bias mismatch types a tensor and a dense. Okay. So this is being cast to a dense, and this is a tensor return. What if I just make it a float? Can this thing handle for that for me? No, it cannot. Okay, so var bias t dot tensor equals t dot new. Here we go. T dot with backing, and then just a 2. And nope, still something's wrong. Invalid operation operator plus not defined on dot product variable of type tensor. Okay, fine. So okay, fine. So dot product dot let's just get like the value. That's scalar value. I want the scalar value of the dot product plus the bias. Something is still wrong. Maybe if we make bias back to being an integer. This is fun. We are figuring out how to use this library firsthand. Okay. 2.0. All right, no, still something's wrong. What's wrong? Invalid operation dot product dot scalar plus okay mismatch types interface and float 64. Okay, I don't know how to deal with an interface. Float 64. I don't want bias to be a float 64. I want it to be a float 32. Just float. Let's see if we could cast it to a float 32. No, you cannot cast that interface to a float 32. What is the scalar value? It returns an interface. What is an interface? I don't even know what it is. Need type assertion. Okay, hold on. Let's just print out the dot product between these two things for now. Let's just print it out. fmt.println, because this is going to print out both an error and the dot product, I believe, or rather the dot product and the error, right? No, I don't want to tidy it. I want to run it. Thank you. Okay, so it's printing out 2.8002, and then also nil. So what if I do the first index value? Can I index things like that? No, I'm not allowed to index things like that. It's not fair. How do I get the first value? Where single value is expected, two valued t dot dot, value of type rect val, where single value is expected, compiler. How do you get the first value of a function that, let's Google it. Get specific value to returns Golang. Golang program that uses multiple return values. Let's see. All right, so this thing is returning 2 integers. Let's see how you can interact with that. Yeah, I get that. You're getting the max and the min, thank you. No, I know how to do it. I want to know how to get the first value of it. Yeah, so this is returning 3 integers. How do you get, is there even a way to do that? Like, there should be. You can't just get the first one. What does it even return it as? Like, what does it even return the 2 values as? It returns it as like a slice, no? Yeah, there's more documentation on that. T dot dot. Yeah, fine. So I'll just say dot product comma that colon equal. This is one thing that's a little bit annoying about Golang is you kind of have to have many lines to do one very simple thing, whereas Python you can do one thing and like many things in one line, and it's much nicer like that. Okay. So this is printing out the dot product, but it's of type tensor, right? So I want it to be of type scalar. Like I want it to be of type float 32. But this is giving a type of interface, so yeah, I guess cast from interface to float Golang. Convert interface to float, converting unknown interface to float. Dave C has a good answer using reflect. Nah, I don't like this. No. No, I don't like that. Actually, wait, hold on. That might have been good. That might have been good. That might have been useful. There might have been something there. Oh, we want. No, we want. What? This is getting to a point of Golang that is way more than I've ever done. Like I've never really dealt with interfaces like this. What is this even? What is a float 64? I have no idea. Bias is a float 64 right now. So what can we add them? Plus bias. No, we can't. Why not? Because it's a mismatched type. There's an interface and a float 64. So what is the interface? Float dot what type? Can I do a dot type? How do you get the type of things? Ugh, why do I keep closing that thing? Convert. See, I'm not even that good at Golang. Yeah, it's dot parentheses type. Is that the syntax? Dot parentheses type. Is this syntax? No. dot type outside of type switch. Yeah, you need a switch statement. I don't know. Let's just do the switch statement. Switch I colon equals that, and then let's just have a default case. Default fmt dot. Yeah, no. Oh, forget it. Forget that whole thing. Scalar. What do you mean? Okay, hold on. I shouldn't even need the scalar value. I should just be able to var bias t dot tensor t dot new. What's wrong? Sorry, just equals t dot new t dot with backing. Not in 32, rather float 64 1, or rather 2.0 because that's the actual value. And let's just say float 32 actually. Float 32. Yeah, so I should be able to use this bias with simply adding the dot product, and the fact that I'm not able to do that is ridiculous. Yeah, there is no. Oh, maybe because t dot add. Yeah, there. Okay, fine. Okay, fine. Yeah, no, that's fine. I understand that entirely. The dot product with the bias. Yeah, so the thing is, Python has like super operators where you get to like define in a given class what adding two of those classes would do, but Golang doesn't really have that, so you have to have a function do that. So t.add the dot product, and I don't think that we even need to do the var syntax because the add thing will take in stuff. So yeah, I think this is fine, and now we are finally on our way to having the correct result, which is 2.4 and nil. I wish there was a way I could get the thing without the nil, so I could just print things out, and so that I could also do these stuff in one line. It's actually a little bit annoying. It actually is a little bit annoying. I kind of want to just get the first value, but I can't do index 0 for some reason. Where single value is expected, two valued t dot dot value of type return value dot tensor comma error where single value is expected. I don't know what that means. Wait a minute. Is that what it means? No. Okay, there's still something wrong. Still something's wrong. I don't know what. Where single value is expected. No. What do you mean too many values? What do you mean too many values? What do you mean? What does it even mean? I just want the first value of this function that you're returning, please. Can I just have that? Get first value of values. There's an ant on my computer. Values returned Golang. I don't know, something like that. Return only the first result of the multiple return values in Golang. No. I'm not taking in. I'm not making my own function to do this. That's ridiculous. The fact, what? There's no way to do this in Golang? No. Okay. No. It's actually not. It's actually not possible. That is a little bit annoying. I'm not even sure how that works. What the heck? Because I wish there was a way to do something. I wish there was a way to do it in something that looks along the lines of, here, like output colon equals t dot add between the dot product and the bias. Yeah, this should be something that you could do between the dot product and the bias, and then you could print out the. But but yeah, you cannot do this because you cannot conditionalize one variable with two, because the dot product is returning multiple things and everything is a mess essentially. Yeah, I want to get one of those values, please. Oh, that's so frustrating. There's really no way to do this? There really should be a way to do this. I'm honestly like flabbergasted that there isn't. I'm sure that there is because it's so necessary to make like clean code. Because I know Golang does their error handling in this way, but honestly, like, yeah, honestly, this should not be how it's done. I don't really like the way error handling is done, honestly, in Golang. It's the only real issue I have of it, and this is the only real reason why. Like, I honestly was pretty okay with it until now, but I can see this being a little bit annoying in the future, and I kind of want to figure this out before we move forward. If there's a way to figure it out, if there is a way to do it. Golang function returns multiple values, get first one. In Golang we can return, yeah, I know you could do it. I know you could do it. Return only with the first result of multiple return values in Golang. Yeah, this is basically the thing that we just saw, right? Result, return result. There's no one-line solution without introducing a helper function that accepts two arguments and returns the first. One of these helper functions would be needed for each combination of types. Yeah. Yeah, you need a helper function, apparently. Okay, fine. So we're just going to have to do it in a Golangy syntax. I guess that's what this is all about, translating the book from that into Golang. So, okay, so we have the inputs, the weights, and the biases, and now we finally figured out how to do the dot product on it and get the output. So let's just say dp for dot product equals t dot dot between the inputs and the the weights and the inputs. That's going to be important later. Inputs. We good? We good? Sorry, it looks like I disconnected for a second. Looks like we're back. Let me just make sure. Yeah, it looks like everything's fine. I have no idea why we disconnected. I'm not sure even when we disconnected. So anyway, we have, let's just go through the lines. dp comma underscore colon equals dp t dot dot. We're making the dot product between the weights and the inputs. The output is t dot add between the dot product and the bias, and then we are just printing out the output. Okay, go run that. And so now we have basically what we had in the last episode, but with NumPy, which is better because it's cleaner. Or rather, not NumPy. We're using Tensor. He's using NumPy. NumPy is way cleaner because he has 1, 2, 3, 4, 5 lines of code total, and we have 1, 2, 3, 4, 5, 6, 7 lines of code total. So we have 2 more lines because right here. That's 2 more lines. Okay. And then here he's visualizing the math. What is np dot dot between these two things? Well, that is equal to the first index times the first index of the second one, plus etc., like we've established before. Okay, now let's do a layer of neurons, and he's going to do it with NumPy, and we're going to do it with Golang. So here's his code, and let's just do exactly this. So the inputs are the same. Now let's make a distinction between the inputs, weights, and biases, because they're all a little bit different now. So the weights is going to be a new thing. And then t dot with backing, so we could say here, right over here, let's break it up. Raw weights colon equals float 32, and then we could just kind of, but it's not going to be, it's going to be multidimensional because there are going to be several weights. There's going to be several like sets of neurons, several sets of weights because there are going to be several neurons. No, I don't want the 2 brackets, sir, please. Okay, so now let's open this up. We have all of his values, but we're going to make it our own Golang values. So very simply, you get rid of the bracket, and we don't want it to be brackets. We actually want it to be curly braces. So we're going to do that in a second. Okay, right over here. This one, this one, this one, boom, and then that's one curly brace down, and then for here, this one, and this one, boom. So there you go. There's our weights, or rather our raw weights, and now let's turn those into tensors. So by going over here, we could just put in raw weights. Very good. And the biases, do they need to be? Yeah, I guess they should be tensors. So 2, 3, and 0.5. Okay, and now over here, he's doing the dot product between the weights and the inputs. So everything seems like it's working out. And honestly, we could probably just run this and it will be correct because we're putting the raw weights over here. That's being turned into weights. And then the biases are like this. And then that's adding. And yeah, I think this should work. So let's run it. Let's see. Let's hope. Let's pray. No, okay, well, that's interesting. Clearly there was an error somewhere. So let's take a look. Error. If error does not equal nil, fmt.println error, and let's copy this line as well. Okay, let's see. Let's see what the error is. Okay, add failed. So the adding failed. Why? So first of all, the dot product worked apparently, so we could get rid of this. The dot product worked. Expected scalar to have the same data type as tensor, float32, got nil instead. Interesting. Interesting. What was the dot product? Let's get rid of this for a second. Let's break this into steps. Let's break this into steps. fmt.println dp. Run. Nil. Okay, so the dot product did have a problem. That's interesting. What was the problem? Oop. Println error. Something did go wrong. Failed to perform dot product. Got float dense. Only handles floats. Got instead type is not a member of float. What? What are our weights? Let's print out weights. Error declared but not used. Let's get rid of that for a second. Yeah. Are they not? Did I mess something up somewhere in the copying and pasting part of the whole thing? 1, 2, 3, 4. 1, 2, 3. I don't know. Weights dot shape. It's only a 3? Why is it only a 3? That makes no sense. I guess we have to do a... I guess we have to pass in what the shape would be. I guess we have to pass in what the shape would be. If we're going to do a multi-dimensional thing. T dot with shape. So we have to tell it what shape it's going to have. So it's going to have a 3, 4. That's the shape. With shape, with shape. Okay, and now let's print out the shape of weights. Error. What's wrong? Shape mismatched. Expected 3, 4, got 3. Hold on. Something is very weird. Oh, you pass in just a raw list and it has to... Oh wow, that's crazy. That's a really stupid way of making arrays. That's a really bad way of making arrays. Yeah, that's really stupid. You can't just pass it in with the... Wow. Okay, so apparently you have to pass in a one-dimensional list and then pass in the shape option and it will figure things out for you. which I guess in some ways is nice, but I suppose in some ways it's also not nice. I'll look into this and see if there's a better way to do things, but yeah, the point is, yeah, if you do it that way, the way they want you to do it, yeah. Okay, we're gonna have to look into that because that's not gonna work. Clear. The point is, yeah, if you do it the proper way, if you make it a one-dimensional list and then you pass it in with the shape option that you want, then you can do everything, and you get a 4.8, a 1.2009, and this, which is exactly what he gets over here, 4.8, 1.21, and then yeah, everything is exactly the same. Am I still alive? Yeah, I'm still alive. Okay, good. Right, let's see if they have any documentation about how to make. So here's one way. Here's another way to make a tensor. You could do it with backing. You could do like a range thing from 0 to 24, and then this kind of shape, and so then you get the range thing, which is interesting. I guess t dot range returns you a range of like a slice between 0 to 24, which is nice to know. This example will cause a panic. Okay. There's gotta be a better way to type array struct storage.header t data type interface equals new of float t dot of float 64 new with shape. This panics. You need to have the data type in. I guess this just starts off at 0, and then this works. It returns you the dense, like the one-dimensional tensor. Float 64 with engine, my engine with shape. I don't know what this means. You may also pass in an engine. If that's the case, the allocated will use the. I'm not sure what that means. I'm not sure this is something more advanced. Yeah, I guess this is how you do it. That is interesting, to say the least. Yeah, that's a weird way of doing things. You pass in a one-dimensional list. I don't know why they would do it that way. Why don't you just pass in a two-dimensional list? That way things are structured better, but I guess, yeah, you have to do it this way. It's not too bad. You just have to pass in the raw thing, and I guess you could structure it like this without the braces, and it's not the end of the world. Probably is better for memory. There are upsides. Anyway, moving on. We did it. We're done. Okay. I think that we'll leave it here for now. So we've turned everything. So we've gotten an understanding of what tensors are. We've converted what we've had before, which is a layer of neurons, into the tensor notation, which, as you can see, is much shorter and much cleaner. Although it's not as clean as Python is, I'll admit that, but it's very clean. It's very nice. And yeah, I think that we'll leave it here for this video. I guess we're not going to finish up chapter 2 in this video. We're going to have to do that in another video. Yeah, definitely going to have to do that in another video. So, good. I hope you guys enjoyed. And yeah, I'm going to end the stream. I'll see you guys in the next one. I'll put timestamps in the video to make things easier. And yeah, see you guys. Bye.